grade 7. Welcome to Math with Mr. S. You were just reviewing how to find the perimeter and area of a rectangle and are now going to consider with me how to find the area of a parallelogram. So you just looked at the idea that if we have a given rectangle, I'm just going to draw one here, hopefully that shows up okay. If we have a given rectangle, we can find its area by multiplying its base times its height. Sometimes people use the language length times width. It doesn't really matter what we call it. But the area will be the base times the height. I'm just going to switch to pen in case that's not showing up very well. So in this case, the base is 1, 2, 3, 4, 5 graph paper units multiplied by 1, 2, 3 graph paper units. And so that's 15 units squared. Now let's take a look at our parallelogram. When a lot of people first consider this, they're asked to find the area, they make a fairly logical conclusion, which is that they will need to find the base and then the height along this edge. We're going to try that for a moment together and see how that works out for us. So if I consider my base, I'm just going to measure this in centimeters. And I have the 0 at one end of the base, and I can see I'm at 17.7. So for this one then, the area, base times height, the base part is 17.7, and then I have to find the height. So we come along and we measure, what is that other edge? What I make here is about 12.6. So let's pop that in, and then we will multiply and figure out what it comes out to. So we have 17.7 times 12.6, and there it is, 223.02 centimeters squared. That is a way that people want to approach this initially, but we're going to see in a moment there is a problem here, and I hope that you're going to be able to identify that problem. This parallelogram, I'll show you fairly quickly, can actually be represented as a square. If I take that piece off and I just add it on to the other side, here it is, sorry, not a square, but a rectangle. So again, what we had a moment ago was a parallelogram. But if I take that piece off and bring it here, you can see that really, in some sense, it began life as a rectangle. If we wanted to get the area of this rectangle, we would have to get its base times its height. So let's try it. So the base appears to be identical to what we had before. So if we've got base times height, we still have the 17.7. But now let's consider the height of the rectangle. And here, I don't know if you can see it on camera, but I'm lining up right here at 11.4 centimeters. And you will see already that calculation is going to be different from this one. I'll just pop it into the calculator with you for a moment. We have the 17.7 still, now times 11.4, and that's 201.78. Now let's consider this for a moment. Here is a rectangle, and we know beyond doubt that its area is this. And I think it's fairly obvious to say, well, if I cut a piece off that rectangle and move it to the other side, that really doesn't change its area, actually. We have exactly the same amount of paper here as we had before. So that tells us that this cannot be right. And probably some of you are already figuring out, ooh, I know what the error was. And you're right. We did fine when we measured the base. That actually does not change, interestingly, when you switch the triangle over to the other side. But it's this measurement that threw us off. This is not what we need for the area of a parallelogram. What we need is the height of that parallelogram. So once you determine what your base is, your height can be measured anywhere along the parallelogram, provided that the line you are measuring runs at exactly 90 degrees to the baseline. And that, I don't know if it's visible on camera there, but that's this line that we measured for our second calculation, the one that runs from the bottom up to the top. So it's the base multiplied by any line that runs directly from the bottom to the top at 90 degrees to the base. That becomes the height. And that's how we get the height of a parallelogram. Now there's a few special cases to consider. Sometimes we can get a parallelogram that looks like it's going to be hard to get a height out of it. And forgive the freehand sketches here, but I'm trying to save a bit of time. So here's a parallelogram. And we could measure the base here. But where do we get a height? That's really not the height. This is really not the height. That's not really the height. So in these cases, what we have to do is extend the base outward, absolutely the same line continued out, and then find where the 90-degree line, the line perpendicular to that one, meets the top point of the parallelogram. So that's going to be right there. I'm at 90 degrees and I'm reaching the top. And so this then becomes the height of that parallelogram. From the top of the parallelogram to that extended line, provided that we are at 90 degrees, then that's the height of this parallelogram. And that brings us to the last concept, which is if you can find the height by extending that baseline, then I'd like you to consider for a moment this parallelogram. So again, I think we'll make it 3 across the base, and I'll hook it up to 3 up here, and this one I'll draw a little bit more accurately than the last one. So this parallelogram has an area that can be calculated by taking its base and multiplying it by this thing, the height. And now let's consider a second parallelogram whose area is actually identical to that one. So I'm going to extend the top of the parallelogram outward, and then I'll extend the base of the parallelogram outward. And I'll start another parallelogram right here. Now, you can see its base is the same. It's the same 3 units as that one. And although this may get a little ridiculous looking, just stick with me. So here is one edge of the parallelogram, and here is the other. So here we have a very stretched out parallelogram. Base is 3, same as this one. What is the height of this parallelogram? Well, it's actually the same as this one, isn't it? Because if I come down at exactly 90 degrees to the base, this height is the same as that height, which means this parallelogram must have exactly the same area as that one, since area is just base times height. And you can stretch this off right off the page to a sublimely ridiculous distance until this thing becomes so thin you can barely see it. And as long as the base and the top remain separated by the same height, the area will be exactly the same. So I'll leave you with those concepts. You can check back in at Classroom for the assignment today, and I hope it goes well, and we'll see you for the next one. Bye.